So today we're going to do subsets. And what are subsets? So we say if A and B are two sets and all the elements in A are contained in B, then we say that A is a subset of B. Now, what does that mean, right? If A is a subset of B, and remember subset, the symbol is a sideways U, right? If A is a subset of B, all the elements in A must be in B. So therefore, B is the larger set and A is the smaller set. So an example of this, we would say, let B be equal to X values such that X is between 1 and 10, and A is even numbers between 1 and 10, inclusive of 10, right? So we could list the members of the set B. So B would be 1, 2, 3, dot, dot, dot. Remember, this is the ongoing symbol to 10. So it's all the numbers between 1 and 10. And A would be 2, 4, 6, 8, and 10. You can say that all the elements in A are contained in B. And you know what? Let me write out these things. I will show you all definitely, just in case anybody have a problem. So 4, 5, 6, 7, 8, 9, and 10. You can see that all the elements 2, 4, 6, 8, 2, 4, 6, 8, and 10 are contained. Therefore, A is a subset of B. Now, we're not trying to write as C, right? You have to elongate the symbol, right? So that's what subsets really are. Subsets say that one set belongs within another set. So not a subset of, right? So the symbol for not a subset is the same sideways U, but you're crossing it out. The cross out means that is not a subset of. So an example of this, and remember from the previous note from the last class, all the elements have to be within the other set for it to be a subset of. If we have some elements, but not all, it is not a subset. So just like the example we had before, in fact, I can use that example. Let me use this here. So if B is 1, 2, 3, 4, 5, 6, 7, and A is 2, 4, 6, 8, we cannot say that A is a subset of B. Why? Because even though we have 2, 4, and 6, 8 is not an element of B. So therefore, A is not a subset of B. So universal sets. Now the symbol for universal sets is this. And you have to pay attention to that there. That little sign or cursive before the U represent the universal set. Right? Now the universal set is the set where all other subsets are derived. Right? What does this mean? So in a particular question, they would give you a universal set. So the universal set, right, represent real numbers, where x is between 1 and let me say 20. If we set A represents even numbers, and you set B represents prime numbers, we can say what the sets, universal set, the set A and set B are, or what they represent. Now, the real numbers will be all the counted numbers between 1 and 20, right? So the universal set will be all the numbers 1, 2, 3, 4, 5, and going straight up to 20. Now, even though this set says even numbers, once it is coming as a subset of the universal set, right, we do not go past the numbers in the universal set. So it's like a restrictive set. The universal set is like a restrictive set. So the set A can only have the numbers, the even numbers between 1 and 20. So you'll have 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20, because 20 is inclusive in the universal set. So it wouldn't go past that. B now, prime numbers. Now prime numbers and numbers can only be divided by itself and 1. So 2, 3, 5, 7, 11, 13, 17, 19, and nothing else. Right? So we can't go further than that. So the universal set is like a restrictive set. So it is where all the other elements, or all the other subsets, can be derived. So A will be a subset of U, right? So A is a subset of the universal set. And B is also a subset of the universal set. So that means that both A and B are contained within universal set. Oh, I don't know why I'm drawing it bad, right? Because if we check all the numbers in A, 2, 4, 6, 8, 10, until 20 are within the numbers. Same thing with B. 2, 3, 5, 7, 11, 13, 17, and 19 are within the universal set from 1 to 20. Right, so the exercise here, write whether they are subsets or not subsets, right, in the line to form the statement, right? So 1, we have the set P representing H, K, J, and R, and we have the set W that has the elements, and that is not the set sign. I need to start drawing it properly for you all. Right. T, E, U, G. Right? So even though we have a common element, do we have a common element? No, we don't have any common element. So this is not a subset. So P is not a subset of W, or W is not a subset of P. Right? So either one you could see. R in this case is 11, 13, 17, 19, and 21. And G is the prime numbers. Prime numbers between 9 and 22. Now the prime numbers between 9 and 22 will be what? 11, 13, 17, and 19. Right? 21 is not a prime number. So we could see that all the elements of J are within, this is the R, sorry, are within the set R. So J is a subset of R. Now I want you all to understand something. Even though J is a subset of R, is a subset. no line scratch off, is a subset of R, right? R is not a subset of G. Why? Because all the elements in R do not belong in G, right? But just in case, you need to pay attention to what letter they put in front. So number 3, we have D, it's pink, red, purple, blue, and Q is red and pink, right? Now they ask, they put D in front, D, Q. But D clearly has more elements than Q. So D cannot be a subset of Q. But we can see that red and pink are both in D. So in this case, we would say that Q is a subset of D. But that's not what they ask, right? They ask if D is a subset of Q. Right? So it is not a subset. So L, 0, 1, 2, 3, 4, 5, and H is even numbers between 0 and 6. So I'll write out what the elements are at one time. So 0, 1, 2, 3, 4, and 5. And H is a set containing the even numbers between 0 and 6, and the even numbers will be 2, 4, and they didn't say including a 6, right? They just say between 2 and 4, between 0 and 6. So they can only be 2 and 4. You cannot include 6 unless it says inclusives of 6, right? So we have 2 and 4, we have 2 and 4. Therefore, H is a subset of L. So H is a subset of L. And number 5, P is pencil, eraser, sharpener. G is marker, crayon, ruler, right? Instead of having to write out all of that. So G is marker, crayon, ruler. P is pencil, eraser, sharpener. We can clearly see that G is not a subset. Is not a subset of P. Sorry, the number of subsets that can be formed or created from a set. Now there's a formula for this, right? So the number of subsets is 2 to the power n. So where S is the number of subsets, and n is the number of elements in the set. Right? So we have an example here, right? So if we have the set L, this is an example. If L is equal to the set 5, 7, and 3, right? The number of subsets that we could have, right, would be, it's not n, sorry, would be 2 to the power n, which is 3 because we have 3 elements, right? And 2 to the third power is 8, 2 by 2 by 2. So we can have 8 subsets from this. And what are the subsets? Right? So each element can create a subset by itself. So you'll have a set with S only. Sorry, 5 only. And that's not looking like a 5, so let me fix it. You can have a set with 7 only. You can have a set with 3 only. You can have a set with 5 and 7. You can have a set with 5 and 3. You can also have a set with 7 and 3. That's 1, 2, 3, 4, 5, 6. Now, an empty set is also a subset. Or another way to write the empty set is to leave out the 0 in the middle. Right? And then we have the set with everything in it. 5, 7, and 3. So how many sets are there? This is 1, 2, 3, 4, 5, 6, 7, and 8. So that's to prove that we can get 8 sets or 8 subsets from this set. Right? Right. So we'll do some questions with this. So V contains the elements of pen and a ruler. Right? So we have 2 elements. Right? So the number of subsets we would have be 2 to the power 2, which is 4. So we know if we have to write out subsets for this, it will be 4 subsets. So the subset will be, let's start with the empty set. And then you'll start, then the next thing you'll put is the full set. And then you will single out each element. So pen will be 1. That's not a set sign. I don't know what that is. So pen will be 1 set. And a ruler will be the last set. Right? And there are no other combinations that we could put. So the set D in 2 is 5, 9, and 6. So the number of elements we have is 3 elements. Now remember, elements is each item in the bracket, right? And S, this number of subsets, will be 2 to the power 3, which is 8. 2 by 2 by 2. So we have to get 8 subsets. So what the subset will be again? Again, the first thing you'll write is the empty set. Then we'll write what the full set would be. So 5. And why we do it like this is to get it out of the room. Then we will write the first element by itself, so which is 5. And the second element by itself, which is 9. Then the third element by itself, which is 6. Then we'll start to pair them off. The first one with the second one. Then 5 and 6, the first one with the last one. If you have any more space, I'll go into the bottom. Let's have a comma here. And since we use 5 with both of them, then we have to use the next element, which is 9 and 6. Right? Let's see how many elements, how many sets we have. 1, 2, 3, 4, 5, 6, 7, 8. So this is correct. And there's no other way we could write it back. So we can't say 6 and 9 because we already have it here. We can't say 6 and 5 because we already have it in this order here. So it doesn't matter the order that they have it in. Right? Number 3. We have L and Y. Right? And we know from the previous example, we're supposed to have 4 subsets because it's only 2 elements. So what will be the subsets? The empty set, the set containing all the elements set containing the first element and the set containing the last element. That's basically it. For 4, the set Z contains one element B. So how many subsets we will have? We'll have 2 to the power n, and we have one element, so we only have 2. Right? So 2 subsets. Now what will 2 subsets will be? The empty set and the set containing B. Now let me do number 5 on the side here. So B is cup, plate, and fork. Cups, plates, forks. Right? So we have 3 elements. So from this previous example, we know that there's 8 subsets. So again, we know the first subset is the empty set. The second subset will contain the 3. Let's subscript it as C for cup, P for plate, and F for fork to try to make up space. Then the first term, which is cups. The second term, which is plates. Third term, which is forks. Then we have cup and plates together. And then we have cup and fork together. And the last one will be plate and fork. Right?